light springs forth from forgotten garbage piles. This ingenious upcycled lamp project demonstrates true innovation and resourcefulness, transforming what many consider waste into a practical illumination source. The initial concept for this DIY light fixture emerged from a clear desire to reduce household refuse and maximize utility from discarded items. Over 2 million tons of electronic waste are generated annually in just one region, so finding new uses for components is vital. This specific lamp began with a 2-liter PET plastic soda bottle as its primary housing, carefully cleaned and prepared. Inside this clear plastic shell, 6 smaller pieces of aluminum foil were meticulously shaped using an old pair of scissors and then affixed with repurposed adhesive to serve as reflective surfaces, enhancing the light output by an estimated 15%. The base of the lamp was crafted from a 3-inch by 5-inch piece of discarded plywood, providing stability and a platform for its internal workings. 2 old circuit boards donated their precious wiring and small electronic components, like resistors and a tiny toggle switch. Specifically, one 220 ohm resistor was integrated to manage current flow, protecting the 1.5 volt light source from overvoltage and extending its functional life. The heart of the illumination is a 1.5 volt LED bulb scavenged from a broken toy flashlight, a robust component often overlooked, but still perfectly functional for thousands of hours. Powering this beacon of ingenuity is a custom 4-cell battery pack, housing 4 AA-size rechargeable nickel metal hydride batteries, providing a steady 6 volts of direct current. These batteries themselves were given a second life, having been deemed too weak for their original application in a remote control, but still holding 70% of their charge capacity, a surprising 1900 milliampere hours. The assembly process involved approximately 5 hours of detailed work, spread over 3 separate evenings, including precision cutting, careful shaping, meticulous wire stripping, and soldering 17 individual components together. Tools used included a small utility knife, a hot glue gun, a soldering iron, and 1 pair of wire cutters. The total material cost for this lamp was precisely $0, a stark contrast to buying a new similar unit, which might cost upwards of $28 for a basic model or $45 for one with comparable features. When fully assembled, the lamp stands roughly 9 inches tall and weighs just under 8 ounces, a surprisingly lightweight structure, demonstrating efficient use of materials. It emits an impressive 55 lumens of warm white light, ample for reading or illuminating a small desk space for up to 7 continuous hours on a single battery charge before needing a recharge cycle. This project diverts an estimated 1/2 pound of plastic and metal from a landfill, representing a small but significant step in sustainable living. The 3 small iteration attempts before achieving perfect functionality highlight the trial and error often involved in such creative endeavors. This human-centered design ethos turns everyday junk into a functional art piece, embodying environmental responsibility, one reclaimed light at a time, saving valuable resources and inspiring future innovation. A sudden, intense glow burst forth from forgotten components. An amazing resurrection. This ingenious upcycled lamp now faced its paramount challenge, integrating the electrical power system after its extensive construction stages. The meticulous 4-cell battery pack, containing 4 AA-sized rechargeable nickel metal hydride cells, was carefully assembled, providing a stable 6-volt direct current for the entire circuit. These specific batteries, salvaged from a high-power remote control, still held a substantial 70% of their initial 1900 mAh capacity, a surprising 80% more than initially estimated, making them ideal for this low-drain illumination project. Connecting the positive and negative leads of this unique custom-built pack to the lamp's internal wiring required very careful soldering, using fine-gauge copper wires from a discarded Ethernet cable, ensuring optimal conductivity and minimal power loss. A small 2-pin snap connector, meticulously fashioned from a broken toy's internal wiring harness, ensured a completely secure yet easily detachable connection for future battery maintenance or replacement needs, allowing for quick swaps. The crucial 220 ohm resistor, previously integrated within the circuit, performed its vital role, acting as a precision current limiter, safeguarding the delicate 1.5 volt LED bulb from the higher 6 volt input voltage. This protection mechanism extends the LED's functional life by an estimated 50%, ensuring many thousands of hours of reliable operation without premature failure. Upon the first cautious activation of the tiny toggle switch, also scavenged from an old portable radio receiver, the 1.5 volt LED bulb instantly flared to life, emitting a steady 55 lumens of brilliant warm white light. A truly satisfying culmination after many intensive hours of dedicated assembly planning. Initial rigorous runtime tests, painstakingly conducted over several consecutive days, confirmed the lamp could sustain continuous illumination for an impressive 75 hours on a single complete full charge cycle, far exceeding all initial performance expectations for such a compact power source. Recharging these robust nickel metal hydride batteries involved a standard smart charger, which could replenish their full 6 volt capacity in approximately 4.5 hours, providing an estimated 500 to 1,000 additional charge cycles before significant capacity degradation would even begin. This unparalleled energy independence represented a core tenet of the entire design, maximizing practical utility from otherwise discarded materials and minimizing external resource dependence. The physical placement of the custom battery pack was carefully considered, ensuring easy access for future maintenance or eventual replacement, ensuring the lamp's multi-year operational lifespan, a design feature enhancing its long-term sustainability. Every single component, including this specially designed battery pack, contributed significantly to the lamp's overall surprisingly lightweight structure, weighing just under 8 ounces, despite its robust power supply system. The careful balancing of voltage and current throughout the circuit ensured maximum possible efficiency, extracting every available joule of energy from these second life batteries, preventing any wasteful energy dissipation. This meticulous power management not only guarantees peak brightness and consistent performance, but also significantly prolongs the operational life of the 1.5 volt LED light source, minimizing future waste generation and maximizing its practical service period over many years of daily use. The entire power delivery system represented a remarkable triumph of resourceful engineering, transforming discarded electronic waste into a dependable, long-term illumination solution, perfect for any small workspace, reading nook, or even emergency lighting situations. A true testament to human ingenuity, it illuminated a room for weeks on discarded power. This extraordinary upcycled lamp defied all expectations, turning what once was refuse into a consistent beacon. Its robust nickel metal hydride core delivered a steady 6 volts for 75 continuous hours, a feat previously deemed impossible for a power source weighing only 227 grams. The integrated 220 ohm resistor perfectly modulated this input, protecting the delicate 1.5 volt LED from premature wear, increasing its lifespan by an estimated 50% over standard configurations. This clever protection meant fewer bulb replacements, reducing waste by several hundred grams over an estimated 5-year operational period. The light itself emitted a pleasant 3000 Kelvin warm white glow, spreading 55 lumens evenly across a 10 square foot area, making it perfect for detailed tasks or a cozy reading environment. Charging the 4 AA cells took approximately 4.5 hours each time, requiring only 0.02 kilowatt-hours of electricity, a trivial amount compared to a conventional 60-watt incandescent bulb, which consumes this much in just 20 minutes. Over a full year of daily use, for 3 hours, this lamp would save an estimated 21 kilowatt-hours, significantly decreasing household utility expenses by around $2.52 based on a 12-cent per kilowatt-hour average. Its total environmental footprint was minuscule, having repurposed nearly 500 cubic centimeters of various discarded plastics and metals, preventing them from reaching landfills. The main casing, for instance, was ingeniously fashioned from a discarded polyvinyl chloride pipe normally used for plumbing, providing structural integrity and weighing around 150 grams alone. The toggle switch itself was part of a 7-piece assembly scavenged from an antique radio, saving another 20 grams of potential scrap. Each component's reapplication represented a meticulous salvage operation, turning what many considered junk into essential parts of a functional device. The lamp's consistent performance throughout hundreds of charge cycles, now approaching its 300th iteration, showcased its unparalleled reliability, maintaining 98% of its original capacity, a truly astonishing metric for repurposed cells. Voltage remained stable at 5.8 volts, even during the final 10% of its discharge phase, ensuring consistent brightness until the very end. This stability was a direct result of careful circuit design, optimizing current draw to a precise 25 milliamperes, maximizing every joule of energy. The entire assembly process involved precisely 300 individual soldering points, each ensuring secure electrical connections and minimal resistance losses. It transformed nearly 700 grams of potential landfill material into a functional asset. The estimated manufacturing cost, if one were to buy these components new, would exceed $45, a stark contrast to the nearly zero direct material cost of this upcycled creation. Its silent operation and lack of heat generation made it suitable for sensitive environments like small animal habitats or plant propagation areas where temperature control is crucial. The total life cycle cost, including charging electricity over 5 years, was less than $15, a fraction of commercially available battery-powered alternatives. This robust and efficient design proved that truly sustainable solutions are not just possible, but incredibly practical, providing reliable illumination without a heavy environmental or financial burden.